Hey y'all, we're going to talk about adding and subtracting polynomials, okay? There's three basic rules you need to go by whenever we're adding and subtracting polynomials. The first is the terms must be like terms to add or subtract. That's very, very important. We've learned about like terms before, but I've underlined it here because it's very important to recognize what is a like term and what is not a like term. A like term is two monomials that are the same. Okay, so a squared and 3a squared are like terms because they have the same monomial. The coefficients are then what we're going to add or subtract. Okay, if I have 3x squared and 3x squared y, those are not like terms because this one has a y and this one doesn't. It doesn't have the same monomial that goes with them. So that's how you recognize whether something is a like term or not. Okay? Now, the second rule that we need to follow is to go through and do additive inverse before you add or subtract. Okay? It's a lot easier to work with adding positive and negative numbers versus subtracting. Okay? So you want to go through anytime there's a subtraction sign and do additive inverse. Okay? And then it's very important that we write our answer in standard form, which we learned about in the last video. Okay? So our first example is we have two polynomials here, or two trinomials that are being added together. So what we want to do is first go through and do our additive inverse. Okay? So anytime we're subtracting, we're going to do plus and negative. Plus and negative. Okay? And then what I like to do to start getting this off is maybe circle or square or highlight the things that are like terms. Okay, so I have negative 2m here, and then I have 5m's here. Okay? Then I have negative 4m squared here, and 5m squared here. And then my constants also go together as a positive 6 and a negative 3. So what I'm going to do is rewrite these in an order to where I'm grouping things together, just like I grouped them together when I was doing monomials, okay? So we're going to have negative 4m squared plus 5m squared plus, let's do my m's now, negative 2m plus 5m, and now let's do my constants, plus 6 plus a negative 3. Okay, now I have next to each other the like terms. My m squareds are next to each other, my m's are next to each other, and my constants are next to each other. Okay, so if I have negative 4 of something, and then I have 5 of something, I'm going to be left with only one of them. Alright, so we're left with 1m squared, and 1 as a coefficient is always understood, so you don't always have to write that. Alright, plus a negative 2m and a 5m is going to be 3m. And then a positive 6 and a negative 3, add those like normal numbers, is going to be a 3. So my simplified polynomial is this. Notice it's written in standard form, my highest degree of 2, then 1, then 0. And I typically write them in standard form starting out in the second step to help me go ahead and organize them. Okay? Alright, so we ready for another example? If you feel comfortable with this, you can always remember, stop the video, try it on your own, then check your work, okay? Alright, so first thing you want to do is go through and do additive inverse. No minus here, no minus here. Alright, negative 9 and nothing else, okay? So now I want to regroup together my things that are like, alright? You can use the highlighter method, the circle, the square method, whatever you like, okay? Sooner or later you're going to be able to recognize what's like and not. So my a squareds, we got 4a squared and negative 7a squared. I got my a's. And then I have my constants, negative 9 plus 12. Okay, now I want to combine what's like. Negative 3a squared plus 8a plus 9, 10, 11, 12, 3. Okay? And this is my simplified polynomial, okay? You know it's simplified whenever there's only one of each like term. If I had another a squared down here at the end, that would not be simplified, okay? Now we're talk a little bit about subtraction. Simply all we did was add those two trinomials, okay? It could be a binomial and trinomial. It could be a very long polynomial. You just need to make sure you look for those like terms. But this one has a subtraction sign in between two trinomials, okay? So what I suggest you do is always go through and do the additive inverse, okay? Leave additive inverse, additive inverse, additive inverse, okay? Now, what this is telling me is I want to subtract this whole thing. I want to make this whole thing negative, okay? So you're going to have to go through whenever you're subtracting a whole trinomial or a whole polynomial is negate everything in here or take the opposite of everything in here. So let's rewrite it. 12g cubed plus a negative 7g plus 2 plus all of this has to go to its opposite. So we have a negative 5. That's actually going to become a positive 5. A negative and a negative 5g cubed, it becomes a positive 5g cubed. And a negative and a positive 9 becomes actually a negative 9g. Okay? So now I have everything in my addition. Now I can move everything around whenever I have addition signs between everything with negatives. Okay? So I'm going to regroup my g cubes. 12g cubed plus 5g cubed. I don't have any g squareds. I have g's though. Plus a negative 7g plus a negative 9g plus 2 plus 5. Okay? 12 and 5 is 17g cubed. Negative 7 and negative 9 is negative 16g's. And 2 and 5 is 7. So this simplified polynomial looks like that. All right, thank you.